ODBC seem mysterious, and lots of sources talk about it in a very abstract way. Let's try to make those abstract concepts concrete by creating a pared down version in pure Python instead of C. For simple use cases, we want to send a query to a database and get a response with the results of our query. We know that ODBC helps facilitate this exchange, but we need to better understand how information is exchanged with the database before we can fully understand how ODBC is helping us. We'll use Postgres as our database and assume the person making the query is using Python. Next, we'll need to understand the Postgres protocol for communication with the Postgres database and the Python PEP 249 standard. First, let's take a look at the Postgres protocol. To communicate with our Postgres database, we need to send messages over TCP from our app to the database. These messages need to follow the Postgres protocol. Two main phases of operation have a separate message format. The second normal operation phase has a character tag, message length, and message payload. We'll just focus on the message payload section, but you can check out the full code on GitHub if you want to dig into other parts. A few examples of the message character tags include Q for query, T for row description, D for data row, C for command complete, and Z for ready for query. Now that we know what a normal message looks like, we can create a query message from a query string. This function adds the message type to the message length to the query along with encoding it to bytes, which can be sent over a TCP socket. To send the message, we'll need to create a TCP socket connection with the database and have a way to continuously receive messages from Postgres. To continuously receive messages, we'll use a Python generator that will continue to read messages from the database until the connection is closed. This code snippet should look familiar to anyone who has used a database with Python, no matter which underlying database is being used. Assuming, of course, that you don't use ORMs. If we dive into the connection object further, we'll see that there are a few key methods that we'll need to create: the cursor, close, and commit methods. To get our connection object, we need to create a method that will use our TCP socket to initially connect with the database. The low-level connection method can be used as part of the PEP 249 connection object. For our simple implementation, we'll assume there will only be one cursor at a time for each connection. The cursor object will handle the interactions with the database once the initial connection has been established. Methods like execute, fetch all allow us to query the database and get results. A simple cursor may look something like this, where it intakes the connection handle, which is basically a TCP socket, and then use it to execute queries, fetch rows, and get column names. Underlying the cursor methods like fetch1 and fetchAll is a processor that interprets the messages from the database as they come in and grabs things like column names and row data. Finally, we have the background we need to create our own simple ODBC driver. A full ODBC implementation may follow the flow of this diagram. You can see there are a few dozen or so ODBC functions defined by the ODBC spec. However, we'll just focus on a few key functions. The SQL Connect, SQL Execute, SQL Fetch, SQL Get Data, and SQL Disconnect functions will fit nicely into our Postgres protocol reader and PEP 249 implementation. This is the minimum we will need to connect to Postgres and execute a SQL query and read the results. To get an idea of what the ODBC spec is, let's look at the SQL Connect function. The spec defines inputs, functionality, and return codes from the functions. In the case of SQL Connect, it takes in something similar to the connection handle and establishes the connection to the database. Only the interface is defined, and it is up to the developer to decide on how it should be implemented. For SQL Connect, this is a Python class that allows us to use our Python functions we created for the Postgres protocol to connect to the database. A minimal example of the querying database with the ODBC functions might look something like the following in Python. It's not too far off from the PEP 249 standard, but it's much easier to understand than a full native C implementation. The following C reference code is provided by Microsoft as an example of an ODBC implementation for a SQL query with SQL Execute usage. Maybe in the future I'll dig in more into a full C implementation of this. Other Python ODBC functions are similarly as easy as wrapping most of our Postgres connection code in the ODBC classes. We are already set up to handle SQL Execute Direct, SQL Fetch, SQL Get Data. In most production use cases, though, SQL Exec Direct is not used in favor of SQL Exec, which allows you to pass parameterized values. Now we can complete the system by combining our ODBC Python implementation with a PEP 249 interface. We can use the SQL Connect ODBC method in the Python 249 connection class, and we can use the SQL execdirect, SQL fetch, and SQL get data functions with the PEP cursor class. This gives us an end-to-end Python native implementation of an ODBC driver. Going through this process has given me a greater appreciation for everything that goes into connecting and interacting with databases in Python. We've peeled back the layers of abstraction around PEP 249 and ODBC and saw how everything is built around the database protocol. How does this give us new perspective on ODBC? And how will this help us in our day-to-day work? First, it makes sense why we don't always need to use ODBC or JDBC with Python. Instead, libraries like PsychoPG implement their own Postgres drivers with Python. As we see, there's overhead associated with ODBC since you need to make your database protocol fit within ODBC instead of focusing on making it simple and efficient. By cutting out the ODBC overhead and interacting with the database protocol directly, PsychoPG reduces any needless abstraction. It seems like there's been a trend where other databases and Python database connectors are dropping ODBC, like Oracle and SQL Server, in favor of this. The takeaway here is that a database offers a native connector that doesn't rely on ODBC. It's probably the one you should be using instead of reaching for an ODBC library like PyODBC. Going through this exercise has also had me thinking about the Arrow format. It is column-based instead of row-based, designed for analytical workloads, but we saw that the Postgres protocol returns data as rows, not columns. It could be interesting to dive deeper into how the Arrow format operates in a similar way, kind of as we looked into ODBC. Lastly, I'm thankful for the people doing the work to make Postgres open source and everyone who creates great documentation around Postgres. It's clear to see there are a lot of layers upon layers of tech needed to make something like Postgres possible. And you can check out more from me on Medium or check out the Postgres community if you want to get more involved with the Postgres project.